Hi, I'm Shelby. I'm an SRE at Equinix, and this is an introduction to tracing-based SLOs. Tracing is great because it can capture just so much data about the state of your service within the scope of each request. And using HTTP or gRPC auto-instrumentation like what we get with OpenTelemetry, it means our traces automatically track things like request duration and status code. So out of the box, we can already measure latency and error rate. Plus, OpenTelemetry also automatically differentiates between client calls and server-side responses, which helps a lot when we want to look at different kinds of workloads. While tracing libraries do a lot of work to keep track of trace state, the actual data they generate is basically just structured logs that have a couple of extra special fields to connect them up. But what those connections give us is the ability to see the relationship between events, and that's why tracing makes such a huge difference for debugging. We get the most benefit from tracing when we're using modern observability tools that accept our raw trace data and then allow us to explore it interactively across lots of different high cardinality dimensions. And that ability to query on raw trace data means we don't have to decide upfront what math to do on what dimensions. Instead, our observability tools do the math on the fly at query time. Of course, we're not redefining our SLOs on the fly. But if your tools support querying across lots of arbitrary dimensions, then they can also support defining an SLI based on equally arbitrary dimensions. This is a big deal. While things like latency and error rate are important for pretty much every service, the most important thing for your service, your key differentiator, well, it's going to be unique to that service. That means you might not be able to measure it with auto-instrumented trace data, which is why it's so important to instrument your code. What's nice about tracing, though, is that the data from custom instrumentation gets interwoven with existing auto-instrumented traces. So rather than sending a bunch of disparate data points, we're enriching our existing traces with more context. And when we define SLOs from trace data, and we go in and add custom instrumentation to measure those most important parts of our service, it's also there the rest of the time to help us with debugging. Who doesn't love dual-purpose data, right? To define our SLIs, we need two things. We need to filter to what's relevant, and we need to define a condition for good. This is the same as any other kind of SLI, but I'll mention that when we're talking about tracing-based SLIs, different tools have different ways of defining your filters and conditions. So in my slides, I'm just using pseudocode. First, let's define an SLI for latency and error rate on overall traffic to our API service. We want to filter to spans that best represent our end user experience. So for overall traffic, we can look at server spans at the root of traces. Here's an example of the kind of span we're looking at. The root span of a trace is the entry point for that request in our system. And so, and for synchronous requests where there's a human at the other end waiting for a page to load or a software service waiting for an API response, the root span tracks the duration of that request. And so it's the right span to look at. We also want to make sure that we're getting an accurate representation of the customer experience. So let's filter out requests from staff users and from internal bot users. And these user fields come from custom instrumentation. Now, we define our condition for good. Remember that OpenTelemetry's auto-instrumentation automatically captures the request duration and whether it was successful. So while you might not be able to filter out staff users, you can add OpenTelemetry like today and define an SLI just like this one and start measuring and observing. Provisioning is our bread and butter at Equinix Metal. So we've been doing a lot of work to instrument and measure the bare metal provisioning process. Our provisions are orchestrated by a background job called provision device job. And here's what that looks like in a trace. This provision device job, it's our best proxy for the end-to-end provisioning process. And the nice thing about tracing our provisioning process is it's also a huge help for debugging, right? This big value. So if provision device job fails, we can go to look at the trace and see which provisioning step actually had the error. For SLI, we also have the ability to filter out test projects we've instrumented for that. So let's make sure to do that because, for example, if one of our devs is enthusiastically reproducing a provisioning error, well, I don't want that to like skyrocket our error budget burn rate and trigger a page and then wake up whoever's on call, especially, we have people, Equinix is a global company. We have people working in different time zones all around the world. So there's definitely a chance for that to happen. So let's just filter out test projects, which are, much more likely to have errors, and they're not impactful. They're not representative of customer traffic and customer provisions. So what's nice about this SLI, though, is these test provisions, these test projects are still generating traces. The data is there for our dev to use when debugging. We're not changing anything at write time. We're just filtering out those test provisions for the SLO at query time, when we're actually querying for SLO data. So now we set our condition for good, and this one is pretty limited, pretty simple. We're just saying it should succeed. It shouldn't error. We're not currently tracking how long provisions take. It is something we very much care about, but there are a few machine-side provisioning steps that just aren't directly orchestrated by our provision device job. So we do have work in progress to improve our instrumentation and better capture those machine-side steps in our trace data separately. So when that lands, we're definitely planning to update our SLI and include that. But nobody ever said that bare metal observability would be easy, right? So don't be intimidated. You can do this. Like, you may or may not be trying to instrument DHCP handshakes, but whatever you're working on, you can start observing, these core things like latency and error rate with OpenTelemetry right now. And then over time, you can go in and add that custom instrumentation to capture the most critical parts of your service. Then once you've observed and learned from this trace data, you can decide, like, is it time to further refine your SLI to make it the best representation of your customer's experience. So thank you for watching. Hit me up, please, in the conference Slack. I'd love to hear from you on Twitter. If you have any questions, or especially if you have cool observability stories, I would love to hear them. All right.